Hello students, how are you doing today? Today our topic of discussion is lipids, and we have discussed in previous lecture about the carbohydrates and their classification, which were the monosaccharides, disaccharides and polysaccharides. Today we are going to discuss about the lipids and their classification. Actually, lipids are the only biological molecules that are heterogeneous group. That is important MCQ that is frequently asked in papers. That is, which group of the biological molecule is heterogeneous? So lipids are the group of the biological molecules that are heterogeneous in nature. What is meant by heterogeneous? Actually, heterogeneous means they are composed of different molecules, like they are comprised of fatty acids and glycerols to different things. So we can say these are called the heterogeneous group of compound. And one is important feature is that they are insoluble in water, due to which, because they are insoluble in water, due to which they are used in the construction of the cell membrane and cell compartments in the cell. And they are soluble in organic solvents like ether, alcohol, chloroform and benzene. Or we can say that they are soluble in polar substances, sorry, non-polar substances, because all the liquids and all the materials or elements that are present in nature, they follow the one rule, like dissolve like. If they are soluble, if they are polar, they will, of course, they will soluble in polar substances, and if they are non-polar, they will of course soluble in non-polar substances. So there are lot of types of the lipids like fats, oils, waxes, cholesterol, etc. Let's start with the next very important question that is frequently asked in papers, that why, and why the lipids store double amount of energy as compared to the same amount of the carbohydrates. Actually, the reason is that because of high quantity or high proportion of CH bonds that are present in lipids are maximum, and low quantity or low proportion of oxygen. Due to this feature, high proportion of CH bond and low proportion of oxygen bond, they will of course store double amount of energy as compared to same amount of carbohydrates. And there are wax and cutin are also examples of lipids. Let's start with the reading that lipids are heterogeneous group of compounds related to fatty acids. They are insoluble in water but soluble in organic solvents such as ether, alcohol, chloroform and benzene. Lipids includes fats, oils, waxes, cholesterol and related compounds. Very important question, why lipids store double amount of energy as compared to same amount of carbohydrates? So the reason is that because of high proportion of CH bonds and very low proportion of oxygen, lipids store double amount of energy as compared to the same amount of carbohydrates. And there are many other functions. Lipids are insulators for heat and cold, and the waterproof material, and protect against the transpiration, excessive transpiration, and prevents dehydration and lot of things. Some lipids provide insulation against atmospheric heat and cold, and also act as a waterproof material. Waxes in the exoskeleton of insects, and cutin, that is protective layer that is present on any fruit, on the cuticle of epidermis of some plants. Organs like leaf, fruit, seeds are some examples of the lipids. Next is the classification of lipid, that is very important. Acylglycerol, waxes, phospholipids, sphingolipids, glycolipids, terpenoids including carotenoids and steroids. Let's start with the first category, that is acylglycerol. Actually, acylglycerol composed of two things. One is the glycerol and one is the fatty acid. And the most widely spread acylglycerol is the triacylglycerol. Actually, the word acyl is used for the fatty acids, And the glycerol is the alcohol that has 3 hydroxyl group. It is called glycerol. And most common, it is an important MCQ, most common acyl glycerol is triacyl glycerol, and it is also known as a triglyceride or neutral lipid. The third name is very important, neutral lipid. Acyl glycerol can be defined as the esters of fatty acids and alcohol, because fatty acids and alcohol are linked with each other with the help of ester linkage. So we have example of ethanol, alcohol, C2H5OH, and the acetic acid, and the product will be after hydrolysis one water molecule removed, OH removed from alcohol and H removed from acid, that is acetic acid here, and the compound will be the ester and water will be as indicated by dotted square. OH is released from the alcohol and H from the acid, and they will form a water molecule. And fatty acids are one of the most important components of the triglycerides. You can see here diagrammatically 3 fatty acids are COOH. Actually, fatty acids are also called aliphatic monocarboxylic acids because they have carboxylic group, and monocarboxylic mean one carboxylic group, and aliphatic represents the no benzene ring and the cyclic structures. 3 fatty acids due to which these are called the triacyl glycerol. Triacyl, as I referred ago, that acyl means fatty acid. So triacyl glycerol, 3 fatty acids and 1 alcohol, that is glycerol here. And after they are linked and H removed from the acid and OH removed from the alcohol, and the bond will be the ester bond here, COC bond, and 3 water molecule are removed. So there are two major types and major categories of the fats or lipids, that there are two major, one are the saturated and one are the unsaturated. Actually, fatty acids may be in liquid state or in the solid state, and these are called actually fats and oils. If they are unsaturated, if the fatty acid that is used in the fats or lipids, if the fatty acids is saturated, then the lipid will be the fat. And if the fatty acid in the lipid is containing a double bond, and we will say it is unsaturated, and this lipid will be called as oils. And the fats are solid at room temperature, and oils are liquid at room temperature. This is the main difference. And animal fatty acids normally straight chain, and plants are normally in branched or ringed. And one more thing that is very important, solubility and melting points. Actually, solubility and melting point are directly proportional to carbon number. As we increase the carbon number in the fatty acids or and in the lipids, solubility and melting point both are increased. For example, as we say C4 butyric acid and C16 in palmitic acid, we can see palmitic acid is more soluble, and the melting point of palmitic acid is also greater, 63.1, as compared to butyric acid, which has the melting point of -8. So these are the major differences. Let's start with the reading. Fatty acids contain even number 2 to 30 of carbon atoms in a straight chain attached with a hydrogen and having a acid group, carboxylic group. They may contain no double bond and will be called as a saturated, or up to 6 double bonds and they will be called as a unsaturated. Animal fatty acids are straight, and plant are branched or ringed. Solubility of fatty acids in organic solvents, as they are only soluble in organic solvents and they are insoluble in water, so we can say that solubility means they are soluble in organic solvents. And their melting point increase with increasing the number of carbon atoms. Palmitic acid is much more soluble in organic solvents than butyric acid. Melting point of palmitic acid is greater than the butyric acid. If 2 carbon are present, it is called the acetic acid. If 4 are present, it is called the palmitic acid. And if 16 are present, it is called the palmitic acid. Sorry, 4 are present, it is called the butyric acid, and 16 is present, then it will be called as a palmitic acid. And the if 18 carbon are present and one double bond is present between the carbon 9 and 10, it is called as a oleic acid. Sorry, here is the steric acid with a carbon 18, not 16, actually 18. 18, that means carbon 18, so it is composed of carbon 18 and saturated. Oleic acid is unsaturated while steric acid is saturated because it does not contain any double bond. Oleic acid is unsaturated fatty acid, not a double bond between carbon 9 and 10. And other fatty acids that are exemplified here are the saturated. Fats containing unsaturated fatty acids are usually liquids at room temperature and are said to be oils. Fats containing saturated fatty acids are solids. Animal fats are solid at room temperature, whereas the most of plant fats are liquids. Fats and oils are lighter than the water and have a specific gravity of 0.8. That is very important concept. They contain less density as compared to water. They are not crystalline but can be crystallized under specific condition. So next topic is waxes, which is very important topic. Waxes, actually you can see the waxes are the protective coating, and in your car you can see the wax. Actually that wax is the waxes. Insects also secrete some time of some sort of wax, and these wax are actually used for the water barrier for birds, animals, and prevents the abrasive damage or friction damage, and prevents the water loss and protective coatings. Actually these are mnemonics here. Key है, it means K for ketone, E for esters of long chain fatty acids, and A stands for alcohol, and A stands for alkanes. Waxes are widespread as a protective coating on fruits and leaves. Some insects also secrete wax. Chemically, waxes are mixture of long chain alkanes with the odd number C25 to C35. Alcohol, ketone, and esters of fatty acids. Waxes protect plant from water loss and abrasive damage. They also provide water barrier for insects, birds, animals such as sheep. Actually, the next there are phospholipids. Just in the lipid portion we are left with the two topics, that is the phospholipid and terpenoids. Phospholipids, actually what are the phospholipids? Phospholipids, the lipids that contain the phosphoric acid, these are called the phospholipids. Actually phospholipids are the derivatives of phosphatidic acid. What is phosphatidic acid? Actually phosphatidic acid contain a 3 hydroxyl group containing alcohol, that is glycerol, fatty acid, and phosphoric acid. Actually in the lipid two components were there, glycerol and fatty acid, but in the phosphatidic acid there are three components. These are glycerol, fatty acids, and phosphoric acid. And if we add some nitrogenous base into the phosphatidic acid, then the resulting compound will be the phospholipid. And phosphatidylcholine is an example of phospholipid. Here you can see the glycerol and fatty acids. On carbon number 2 there are two fatty acids, and on carbon number 3 of the glycerol there is a phosphoric acid, so the compound is phosphatidic acid. One is glycerol, two fatty acids, and one phosphoric acid. The compound is phosphatidic acid. And if we add some nitrogenous base onto the phosphoric acid, the compound will be, that is the nitrogenous base, and the nitrogenous base is a choline. There are so many types of nitrogenous bases: choline, serine, ethanolamine, and many more. The compound will be the phosphatidylcholine. It is also known as lecithin, and you can see the bend in the tail that is present due to the unsaturation. And you can see phospholipid molecule, and the bend in the structure is due to the unsaturation. And you can see the polar head, that is a hydrophilic, it means water loving, and the tails are the hydrophobic. It is a actually phosphate containing region that attract water, and it is a hydrophobic region and fatty acids region. Let's start with the reading. Phospholipids are derivatives of phosphatidic acid, which are composed of glycerol, fatty acids, and phosphoric acid. Three things present are phosphatidic acid. Nitrogen species such as choline, ethanolamine, and serine are important component of phospholipids. They are widespread in bacteria, animals, plant cells, and frequently associated with the membranes. Phosphatidylcholine is one of the common phospholipid. So, next topic is terpenoids. These are very simple. Actually, these are some uh, sorts of rubber, carotenoids, steroids, terpenes. These are all the terpenoids, and these are made up of the isomers that are called the isoprenoids. And these are also some sort of a complex molecules that form different sorts of rubbers, natural rubbers, and different types of steroids hormones. These are the complex compounds than the all other types of the lipids. Terpenoids are very large and important group of compounds which are made up of a simple repeating units, isoprenoid units. This unit by condensation in different ways give rise to compounds such as a rubber, carotenoid, steroid, and terpenes. And at the end there are some functions, as we already discussed. Few the repeating functions are here. Lipid constitute a major source of energy and play an important role in the structure of membranes because it is insoluble in organic solvents, so play important role in the structure of membrane and organelles found in the cell. They also provide insulation, mechanical protection, and protection from water loss and abrasive damage. So this was all about the lipids. If you find any confusion, then ask me. I will be available for you. Thank you very much. Take care.